All right, good evening, good evening. Hope all is well. So this lecture will be on 7.4 properties of triangles. So we have our similar triangles, that's where we'll start. Similar triangles, similar objects by themselves have the same shape, but not necessarily the same size. Okay, so when we look at properties of similar triangles, the ratio of corresponding sides are going to be equal. The ratio of corresponding heights is equal to the ratio of corresponding sides. And the measure of corresponding angles are equal. All right. So just a quick example of what we mean by that is that if I have these two shapes, these two triangles, and they are similar, what we're saying is that the ratio of their sides will be equal. So when I look at AB and DE, if I do AB over DE, that will simplify to 1 over 3. That's 2 over 6, which will simplify to 1 over 3. Then if I look at BC and EF, small angle over larger, small triangle over larger triangle, that would be 3 over 9, which would be 1 over 3 as well. And then if I look at that last side of AC over DF, that would be 4 over 12, which is equal to 1 over 3. So the ratio of the sides will be equal. And that fact, that key will help us to be able to solve missing sides in our similar triangles. So if we have triangles ABC and DEF, and we know they are similar, we can find the height, which would also have that similar ratio, or that similar ratio will be created by looking at our heights. All right, so we have here in the smaller triangle, the height of it is 4, and then that bottom side is 8, both of them in centimeters. In the larger triangle, the height is what we're trying to find, that is FG, and that bottom side is 12 centimeters. So what I can do is set up the ratio of AB over DE. Those are the two sides that we know. And then CH over FG. This ratio, in the ratio setup, we just have to make sure that we stay consistent in what we're doing. The easiest way to do it is to do small triangle over larger triangle. Let's go call it big for short. Or I could have done big over small. There are other ways to set it up as well, as long as you stay consistent, but it's the easiest way. Either do small over big or big over small, and make sure you keep that consistency in both of your fractions to set up your proportion. So notice this is my AB is my smaller side, DE is my larger side, CH is my smaller side, FG is my larger side. I'm talking about the size of the triangle. So now we can go ahead and plug in numbers. AB is 8, DE is 12, CH is 4, and FG is unknown, so we can call it X or call it whatever variable you like. Now we can solve by doing cross multiplication. Always take your denominators up to the opposite numerator. So on the left, we will have 8 times X, and on the right, we'll have 12 times 4. Now I can solve by dividing both sides by 8. You always divide by whatever number is sitting in front of your variable if you're trying to solve for your variable. And then 48 divided by 8 will be 6. So that's the answer. The height of your triangle would be 6. The height of the larger triangle would be 6. All right. Still dealing with similar triangles. All right, let's look at this. All right, so here we have if the three triangles, excuse me, if the three angles in one triangle are equal in measure to the three angles in another triangle, then the triangles are similar. So they're just giving you a way to determine if you have similar triangles or not. So if the three angles in one triangle are equal to the measure of the three angles in another triangle, then the triangles are similar. And then one more. All right, so then they give you another way of looking at it, saying that if you have your two angles, if there are at least two angles of one triangle that are equal in measure to the two angles of another triangle, then the triangles are similar, and that is because if you look at two different triangles, I guess I use green for the other one. And let's say you know that this one is equal to this one. Let's do one slash. This one is equal to this one. Then you know that these two would also have to be the same. And that's because the sum of the angles in a triangle is 180 degrees. I believe we mentioned that already in one of the previous videos. So if you know one is 60 for both of them, then the other one is 20 for the both of them, then that means that the third angle for both of them would have to be 100 degrees. All right, so what they're telling you is that you at least need two angles to be the same in order for you to know that you have similar triangles. All right. All right, so I haven't drawn the figure yet, but it says in the figure, angle B and angle D are right angles. AB, that's the side AB is 12 meters, side DC is 4 meters, and AC is 18 meters. Find the length of CO. All right, let's see if I can draw this well. All right, AB is 12. They say that D and B are right angles, and they have AC. AC is the long line, and that is 18 meters. Oh yeah, DC is 4 meters. All right, so let's look at how we can match this up. We want to be able to set up our ratio like we did last time. We have a smaller triangle up here, larger or bigger triangle up down here. So we want to set up our ratio as small side over big side. All right. So making sure we see the matching up of our corresponding angles. Don't forget vertical angles are equal. So these would be equal. So if those angles are equal, then that means these angles are equal as well, because we already know that one of them is 90 degrees. So that makes or lets us know that we have similar triangles because all of the angles are equal. All right. If they were not similar, then we couldn't do the whole ratio thing. So now the bottom side that's are equal. Notice we have the double slash and the 90 degree here, double slash 90 degree here. That lets us know that those are the corresponding sides. So that's the first part of our setup. That'll be 4 over 12. And then looking at AC. So we know that that whole side of AC is 18 meters. And so what we have to do here is call one side X and call the other side 18 minus X. So we can call this side X and then call this 18 minus X. Reason being is because we don't know the length of either side. It's not necessarily split in half, but we know the total. I could have switched it up and called A0 or AO X and the other side, which was CO 18 minus X. It doesn't matter as long as I do my mathematics correctly, I'll still get the same answer. I just need to make sure that one of them will be X and the other one is the total, which is 18, 18 minus X. Okay. So my smaller side, I said, is X. And the larger side that corresponds to that is the 18 minus X. And now I can cross multiply. In which on the left side, I will have 4 times 18 minus X. On the right side, 12 times X. Distribute the 4. 72 minus 4X. That's 12X. Add 4X. That's 72 equal to 16X. And then finish it off by dividing both sides by 16. X is equal to 4.5. That would be meters. All right. And remember, X represented CO, and that's what we were looking for. So our answer is 4.5 meters. All right, two more things in this section, and we'll be looking to close it out. Looking at first congruent triangles. So they have all right, so let's look at our theorems. So the side theorem. All right, so the side theorem, if the three sides of one triangle are equal to the corresponding three sides of another, then the two triangles are congruent. All right, if the two sides and the included angle of one triangle are equal to that of a second triangle, the two triangles are congruent. So when you say two sides and the included angle, if you're talking about this side, and this angle right here, that's what it means to be an included angle. All right, one more theorem. And then the last one, last theorem, I should say, angle side angle. If two angles and the included side of one triangle are equal to that of another, the two triangles are congruent. So it says two angles and the included side. So talking about this angle, this side, and this angle. So two angles and the included side, the included side. All right, so let's see if we can make sure we're good with determining if triangles are congruent. Let me see if I can do this better. Okay, so the first one, the triangles congruent. We have 45 degrees in both triangles, 80 degrees in both triangles, and 55 degrees in both triangles. Are they congruent? And if you go back to our theorems, we have three. We have side, 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 and angle, side, angle. We do not have an angle, angle, angle. That's what we have in this scenario. So these triangles are not necessarily congruent. If they are, we need more information. We cannot go off of the three theorems that we have. All right, looking at the next one. All right, so in this one, PQRMNO. So we have 18 centimeters, 60 degrees, 17 centimeters, and then on the right, 16 centimeters, 60 degrees, and 18 centimeters. So these triangles are congruent. They are congruent. Let me write that better. Congruent. And the theorem we would use is side, angle, side. All right. All right. One more, and then we'll be done with this section. Looking at our Pythagorean theorem. All right, so I think I like writing, drawing it the other way. All right, so your Pythagorean theorem, a few things about it, only used for right triangles. C is always the hypotenuse C is always the hypotenuse. C is always the longest side and opposite 90 degrees. C is always on the side of the equation alone. And then last one, A and B are interchangeable. Doesn't matter which one you call A and B. As long as C is on one side of the equation by itself. And just going back, I'll scroll back down. You got A squared plus B squared equals C squared. A and B are considered legs when C is your hypotenuse. So that's leg squared plus leg squared equal to hypotenuse squared. And so, like I said, A and B can be switched up, but C is the one that has to be specific. You cannot switch out what C is. All right, your hypotenuse always has to be on one side by itself. So if we want to find the missing side, so they gave us this diagram, asked us to find the missing side. This side is opposite 90 degrees, so that means that's C. That means A, B, and then C is the missing piece. C squared is equal to A squared. Well, I'll just write it the other way. So that'll be 5 squared plus 12 squared equal to C squared. 25 plus 144 equal to C squared. 169 equal to C squared. Take the square root of both sides. So you can get that square off of C. C is equal to 13. Don't forget, if C is going to be the longest side, then you can compare it to A and B and make sure that C is not coming up short. And that's how you will find your missing side. So try this stuff out, see if you get stuck. Make sure you pay attention to the directions of your homework assignments. If they ask for decimal values, make sure you go the proper amount of decimal values out. Square root of 169 was an even root to take, but it is possible you could get one that is not even, so you take the square root of it, then give the proper amount of decimals. Outside of that, try it out, see if you have any questions, and let me know. Have a good one.